All right, IBAA SL 1. Today we're going to do some work with the binomial distribution. So, first thing here, we're going to start with an example before we get to what a binomial distribution actually is. Determine the probability of getting 2 heads in 3 tosses with a biased coin. So this coin is not fair. It's not a 1/2 and 1/2. The probability that you get a heads is 2/3. 2 out of 3. So the problem with this is that in 3 tosses, there's several ways that you can get 2 heads. And we've been doing a lot of warm-ups like this where, like, it could be head, tails, or it could be heads, tails, heads, or it could be tails, heads, heads. So there's 3 different ways this can go. So what we have to do is find the probability of each of those and then add them all together. So this would be, the probability of exactly 2 heads be equal to the probability of heads, heads, tails, plus probability of heads, tails, heads, plus the probability of tails, heads, heads. Now, the thing about that is that all 3 of them have the exact same probability, because it's going to, it's independent probability. One's not going to affect the other. So the probability of getting a heads is 2/3. Then, times another 2/3 would be 2/3 squared. And then the probability of a tails is 1/3. Now that's just the probability of one of these instances. But since there are 3 of them that all have the exact same probability, we can just put a 3 on the outside here. So, some things to take away here, and I'll switch to a different color. This is number of ways a success can happen. I'm going to put this very generally. This is the probability of success. This number right here is how many trials you're looking for, or how many of the expected outcome. And then this is the probability of non-success, I guess I'll say. So everything, and then, I'm sorry, if you crunch that out, I don't know if we actually need to crunch it out, but it's 4/9. If you actually multiply that all out, it's 4/9. So you guys, this structure right here is basically a binomial distribution structure, and here I'll show you that. The only hard part of this is how you get this number. So with this one, it was there's only 3 different ways it can happen, but picture that we're gonna toss the coin 45 times, and I want to know how many, you get exactly 10 heads or something like that. There's so many different rearrangements of 10 heads in a group of 45. So we're finally gonna let the cat out of the bag that there's a mathematical formula for this. It's called N choose R. So N choose R represents the number of ways of choosing R items out of a group of N items. It's not a fraction. Notice there's no fraction line here. It's just a number over a number with parentheses around it. The way you find that by hand is with factorials. You do N factorial over R factorial times N minus R factorial. Just a refresher that if you were to have 5 factorial, this is 5 times 4 times 3 times 2 times 1. It's all the positive integers being multiplied up to that number. Fortunately for you guys, there's a real easy way to do it on a calculator. So first you have to put a number on your screen, then go to math, then go to PRB, which stands for probability, and find NCR, put it in the middle, then put another number, then hit enter. That'll tell you how many ways you can arrange R items in a group of N items. A binomial distribution for x is a discrete random variable which is binomially distributed. This represents the whole binomial distribution. X little curly q, capital B for binomial, NP. Is the probability of obtaining R successes out of N independent trials when P is the probability of success. So that R is the number of successes, P is the probability of success, and you're doing N trials. The way you find each of these instances, like, the probability for a certain number of trials is using this form right here. First, it's N choose R out front. That's the number of ways that it can happen. Then it's the probability of success raised to how many times you're looking for. And then it's 1 minus P, which is like the complement of success, to the N minus R. Another way to say that is that when Q is 1 minus P, you can write it like this, but it's the same thing. Let me show you guys how to use this. X is binomially distributed with 6 trials. The probability of success in each trial is 1/5. What is the probability of exactly 4 successes? So if I had asked this question before, you'd have to figure out how many different ways you can have 4 successes in a group of 6. But now that we have this, so this is how you'd write this, or I guess I'll put it up here. The whole thing is X is binomially distributed with 6 trials, and the probability of success is 1/5. So if we're looking for the probability that X is equal to 4 successes, this is going to be 6 choose 4 times the probability of success to the number of trials we're looking for, or the number of successes we're looking for, times the complement of success, and then there's going to be 2 unsuccessful ones in there if you get 4 successful. Some things to notice: this number and this number always add up to this number. You should kind of remember that a little bit from your binomial theorem days. Now, if you grab your calculator and do 6 choose 4, that means there's 15 different ways you can have 4 things in a group of 6. 1/5 to the 4th is 1 over 625. And then 4/5 squared is 16 over 25. And then if you simplify that whole thing, probably using your answer to fraction button on your calculator, is 48 over 3125, which is about 0.00154. Part B, what is the probability of at least 1 success? Well, that would be the probability that X is greater than or equal to 1. But just like our last unit on probability, the probability of at least 1 is the same thing as 1 minus the probability of none. So none would be X is equal to 0. So we get 1, take away, just plugging it into the binomial distribution, it's 6 choose 0. Probability of success is 1/5, but then it's going to be raised to the 0 power, and then the probability of non-success is 4/5, and that's going to be raised to the 6th power, which, 6 choose 0 is just a 1, 1/5 to the 0 is also just a 1, so this is 1 take away 4/5 to the 6th, which is 1 take away 4096 all over 15625. And then if you simplify that with your calculator, you get 11529 all over 15625, which is about 0.738. That's it for that problem. Next example, on any morning, the probability that Sam takes the bus to work is 0.4. Find the probability that in a 5-day work week, Sam takes the bus to work exactly twice. So this would be the probability that capital X is equal to 2, which is going to be 5 choose 2. So 2 days out of his 5-day work week. How many different ways you can arrange that? The probability that he takes the bus is 0.4. We want 2 successes. The probability that he doesn't take the bus is 0.6, and there's going to be 3 failures there. So this equals 10 times 0.16 times 0.216, which is 0.3456. Yeah. Also, the way you would write just the distribution in general, I realize it's awkward notation, but it's X, curly Q, capital B, 5 trials, probability of success is 0.4. Last problem. A drug has an 80% success rate of curing someone. A testing company gave the drug to 2 groups of 10. That's interesting. So 2 groups of 10. Find the probability that all 10 patients were cured in both groups. Well, first, we could assume that it's binomial distributed since there are 2 outcomes, success and failure. Success is someone being cured, and failure is someone not being cured. We can also assume that these events are independent because, if one person is cured, that doesn't affect the probability that another person will be cured. So we're really going to do X binomially distributed with 10 people, and the probability of being cured is 0.8. So if we're going to find the probability in just one group of 10 that all 10 people were cured, we're going to set probability of X equal to 10. So in the binomial distribution, this is 10 choose 10 times 0.8, where all 10 people are cured, and then no people were not cured. This is just 0.8 to the 10th power, which is about 0.10737. Now, this is the probability that all 10 people in one group are cured. The question says, though, that for 2 groups of 10 patients, that we want to know everybody was cured in both groups. So the way you can do this is just say it's going to be group 1 then multiplied with group 2. And each of these are going to have a 0.10737 probability. So if you multiply those both together, you get 0.0115. All right, you guys, that's all I have for us for today. Good luck with the homework. Please come ask me questions.